Hi class, you should have received these new notes in the post over the last week or so. So this is what we'll be working on. This booklet is what we'll be working on in the next 3-4 weeks. I'm not sure when lessons end, but we've still got lessons for the moment. So we're having a look at kinematics. Now we did do kinematics a while ago, but we were only looking at constant acceleration. So that's when acceleration doesn't change. And when acceleration doesn't change, you would use the Suvat equations, which is what it says here. Suvat equations, which are valid only when acceleration is constant. We're now looking at cases where the acceleration may vary. And that means we can't use the Suvat equations that you were given earlier on in the year. And rather than S, we're going to use the letter X for displacement. That won't always be the case. There'll be some examples where it'll say S, sometimes they'll use X. But you've got to think about it as being a particle that's moving along the x-axis. This distinction is that X is a displacement from the origin, whereas in Suvat, S was a displacement from the initial position. Origin, remember, is 0, 0. The particle need not start from the origin, so X is not necessarily equal to 0 when t equals 0. Okay, so you may or may not remember, but if you have a displacement time graph, then the velocity of that displacement time graph is the gradient of it. Okay, so if I have got X, which represents displacement, if I differentiate that, it will give me velocity. So dx by dt is velocity. Now, if you think about your velocity time graph, and then if I want to find the acceleration from a velocity time graph, it would be the gradient of the velocity time graph. So if I differentiate v, if I differentiate it, I'm looking over here, I would get acceleration. So you've got to, this is not given to you, you do have to learn this. So I tend to think of it as xva. And then I think I'm differentiating that to get velocity. I'm differentiating velocity to get acceleration. Okay, so I have got, and actually I've got one from my old notes. It's the same thing, same example. Now I have got a displacement time graph here. So, and then just over here it says the particle is momentarily at rest. That means it's stationary. Sometimes they call it instantaneously at rest when velocity is 0. So over here, there's your displacement. When it gets to that point, your velocity is 0 because then it's coming back to its in the other direction now. So it was going away from the starting point, then it's coming back. So it must have stopped at some point for it to come back. And then the velocity is decreasing. And at this point, velocity is 0 because now it's reversing direction again and going in the other direction. So if they mention momentarily at rest, or they're saying instantaneously at rest, they're talking about velocity being 0. Okay. If you can copy this diagram down, so that one there was displacement and time. This one is velocity and time graph. So you don't have this in your notes, so you might want to copy this down. Just pause the video whilst you do that. Okay. So on a velocity time graph, the gradient, okay, the gradient represents acceleration. Now at these points here, the stationary point, that's when acceleration is 0 because acceleration represents the gradient. So at these points here, acceleration is 0. So they could ask you questions about that. Okay, so I'm having a look at this example here. Have a read. You might want to pause the video whilst you have a read. Particle P is moving on the x-axis at time t seconds. The displacement x meters from O is given by this equation here. Find the velocity of P when t equals 3. So I have got the displacement in terms of t, and I want the velocity. Okay, so I know, you guys have got this, haven't you? That if I differentiate, I get velocity. Okay, so what I'm going to do is I'm going to differentiate that. So v equals dx by dt. That gives me 4t cubed minus 32. And the question says they want the velocity of p when t equals 3. So I'm going to sub in t equals 3. And if you sub that in, I do have it already here, but you know, you could work it out. work it out, type it into your calculator. I'm just going to look up the answer to save me a little bit of time. And I have got that is equal to 76. So the velocity would be 76, and I think this is meters per second, so I'll put the units in meters per second. Okay, part B, it says find the value of t when p is instantaneously at rest. So this bit here, instantaneously at rest, they're talking about the velocity being 0. Okay, and I have got that velocity is 4t cubed minus 32. So velocity is 4t cubed minus 32, and instantaneously at rest means velocity is 0. And then you just rearrange that and find what t is. So if you rearrange that, you'll get t cubed is 32 divided by 4, which is 8. And if you cube root that, you will get 2. Okay, so part B done. The last part, part C, the acceleration of p when t equals 1.5. So if you remember, acceleration, okay, there it is, acceleration is velocity differentiated. So what I'm going to do is, there's my velocity, there it is. I'm going to differentiate that to get acceleration, and I'm just going to write it here. So acceleration is dv by dt. So if I differentiate that with respect to t, I will get 12t squared. I think that's it. And I want the acceleration when t is 1.5, so I'll sub that in. And that will give me acceleration is 12 times 1.5 squared. Type that into your calculator and you will get 27. So the acceleration of p when t is 1.5 is 27 meters per second squared. There you go. Okay, so after you've done this example, you should be working on, I'm looking on Active Learn here. If my screen works, there we go. I am looking at, this is the Year 1 Mechanics book. I will put it in your notes, but can you complete exercise 11B? So that will be the exercise I want you to do today. That'll be the first exercise, and then I'm just going to do a video on exercise 11C. So if you turn over for me, that one there. I'm not sure why I'm not using your notes rather than my old ones. But, okay, here we go. I can do it here. Oops, just torn it off. What does it say? Okay, so a child is playing with a yo-yo. The yo-yo leaves the child's hand at time t equals 0 and travels vertically in a straight line, typo there, before returning to the child's hand. The distance s meters of the yo-yo from the child's hand after time t seconds is given by this equation here. And they've said t is in between 3 and 0 inclusive. And it says justify the restriction 0 to 3. Okay, so the best way to do this is to draw the graph of s against t. All right, you could use Desmos, you could use your graphical calculator. If you don't have that, you could just factorize this. I mean, we've all got calculators that solve cubics. So what I'm going to do is I am going to find where this cuts this axis here. And I'm going to do it by putting it equal to 0. And I'm going to go to my calculator. I've got one of the older ones, but your new ones does it. Menu 5. I'm going to go to cubic because I'm solving a cubic. I'm going to put in my coefficients. So my t cubed is minus 0.2. My t squared is 0.4. 0.6t. And I've got 0 as my constant. And it'll give me where this cuts the t-axis. So I've got 3 is one of them, and I have got minus 1, and I have got 0. Okay, so I have got 3 somewhere here, 0's there, and minus 1 is here. So, and this, if you have a look, that's a minus cubic. So you should know that it starts up here, goes like that, does that. So what I'm going to do is I'm just going to draw it. It's not brilliant, but you get the idea, like that. Okay. So I've got to justify the restriction t being between 3 and 0. Okay, well, time can't be negative, okay? And here time is negative. So t has to be bigger than 0, or bigger than or equal to 0, as time cannot be negative. The other bit for t bigger than or equal to bigger than 3. So if I look at t as being is bigger than 3, then I have got that s is negative there. Now s is the distance of the yo-yo from the child's hand, and you can't get a negative distance. You can get negative displacement, but they're talking about a distance, and you can't get negative distance. So t is bigger than 3 gives a negative distance. Which again is not possible. So that means that this is only valid when t is between 0 and 3. So I'm just going to write that. Therefore, model is only valid for t being less than or equal to 3, bigger than or equal to 0. Okay. Part B. Find the maximum distance of the yo-yo from the child's hand. Well, the maximum distance, well, that'd be there, wouldn't it? There's the distance from the hand, 0, at, and then over here would be the maximum distance. And at that point, that's a stationary point. I think I need to differentiate. So I am going to write part B, ds by dt. It's also a velocity, but if you think about it, with a yo-yo, it has to come to rest. So at that point, velocity is 0. The velocity is 0 before it reverses direction. So ds by dt, I'm just going to differentiate it. It's 0.6 plus 0.8t minus 0.6t squared. And I've got to find where this is equal to 0, because that's what you get for a stationary point. And then you can just put that into your calculator. It's a quadratic. So I'm just going to go to menu, equation, quadratic, and I'm just going to put my coefficients. I have got minus 0.6t squared, 0.8t, 0.6. Okay, and it gives me some third answers. 1.87. I'll go with 1.87. And the other one is t is minus 0. something. Can't get negative time anyway, so that must correspond to that value there, but that's not in the interval anyway. So I would get my maximum distance when t is 1.87. So I'm going to disregard this one. But the question said find the maximum distance. It didn't say give me the time when you get the maximum distance. So what I'm going to do, I've got my time, and I am going to sub it into my equation for s and find my maximum distance. Now ideally I'd use a bit more accuracy than that, so I'm going to use 3 significant, let me bring it back up. I could use the exact value, but if I'm going to give my final answer to 3 significant figures, then I need to do work into at least 4 significant figures. So here 1.869 is what I'll use. So t is 1.869, sub into that one there, and if you do that, you will get s equals 1.21 meters. I think that's right. I am going off the book rather than working out myself. Yeah. So you could type it in, but to 3SF you'd get that. Okay. So once you've done this example, I would like you to go to page 187 in the Year 1 Stats Mechanics book and work through exercise 11C. Okay, and we'll stop there for today.